FPSO Brasil is moored on the Roncador field, which lies in very deep water offshore Brazil in the Campos Basin. The field contains large quantities of oil and gas, and these are produced by a number of subsea wells connected to the FPSO by pipelines on the seabed and flexible riser pipes. These wells include some of the deepest production wells in the world. The FPSO is owned and operated by single buoy moorings and leased to our client Petrobras for 5.5 years. She is a sister to the Espadarte FPSO, which has also been producing in the Campos Basin on charter to Petrobras since mid-2000. FPSO Brasil has been designed and built on an ultra-fast-track schedule and departed Singapore only 13.5 months after contract award from Petrobras. The FPSO has three main parts: the turret, which is the heart of the FPSO mooring system, the topsides, which comprise the oil, gas and water processing facilities, and the vessel, which comprises the crude oil storage, accommodation and services. The turret is the mooring system to which the FPSO mooring lines are attached. These hold the FPSO in position over the subsea wells by use of anchors embedded in the seabed. A bearing system allows the central fixed part of the turret to remain geostationary, while the hull is allowed to freely weather vane around the turret in response to the prevailing wind, wave and current forces. Fluids produced from the subsea wells pass through swivels, allowing them to pass from the fixed to the rotating part of the turret and then on to the topside separation and processing facilities. The fluids produced from the wells comprise a mixture of crude oil, gas, water and solids. These must be separated to allow each component to be processed to appropriate specifications for sale or disposal. This is the function of the topsides. The FPSO topsides have been fabricated as a number of modules, which were built in Singapore, Batam, Indonesia and the UK. When completed, these were lifted on board the FPSO and interconnected to form the complete oil, gas and water processing facilities. Each module weighs between 100 and 500 tonnes. Modules 1 and 2 provide the separation system. Here the well fluids are heated and allowed to settle in separator vessels where gas and water are removed from the oil. This produces sales quality oil, which then flows via a metering unit to the cargo tanks for storage until a shuttle tanker arrives for offloading. Water that has been separated from the oil is processed to remove dissolved gas, after which it flows to the FPSO slot water tanks for settling to remove residual oil before overboard discharge. Separated gas must be compressed to high pressure for re-injection into the subsea production wells in order to boost production rates. Subsea gas which is not needed for FPSO fuel or lift gas is exported to a gas pipeline for consumption onshore in Brazil. The gas compression is achieved in two centrifugal machines powered by Rolls-Royce Avon gas turbines. High pressure gas from the compressors must be further processed to remove water before it can be exported for sales or used as lift gas. This drying is achieved in Module 3, where the gas is washed with glycol to absorb all water. Some dry gas is reduced in pressure to allow it to be used as the normal source of fuel for all the FPSO power requirements. All remaining gas is passed through two swivels to the fixed part of the turret, where it is distributed to the subsea wells to assist production and to the export gas pipeline. Electricity needed to power the topsides equipment is generated in two gas turbine driven generators located on Module 12, each providing around 5 megawatts. The power is distributed to all the users by switchgear located in a purpose-built local equipment room located on Module 13. To maintain the productivity of the subsea wells, the oil produced from the reservoir must be replaced with water. seawater, lifted onto the topsides by 3 vertical pumps, is treated to the quality needed for re-injection into the reservoir. A specific requirement for the Roncador field is that the water to be injected must be treated to remove sulfate molecules, and the water to be injected into the reservoir for pressure maintenance is therefore processed in a sulfate reduction plant located on Module 19. After the sulfate reduction plant, the water is further processed to remove all traces of oxygen by subjecting the water to a high vacuum in a large tower located on Module 9. The treated water is then pumped to a high pressure by a gas turbine water injection pump on Module 10. Before being routed through a swivel path to the fixed Parker turret for distribution to the various subsea injection wells. The vessel that forms the basis for the FPSO is a VLCC oil tanker, the TT Mosscliff. Much of the original tanker equipment has been replaced, and that which has been retained has been fully refurbished to meet the FPSO design life. The FPSO will be capable of storing up to 1.7 million barrels of crude oil in its cargo tanks. This produced oil will be offloaded every 10 days to a shuttle tanker, which will approach the FPSO and be moored in tandem to the stern. A floating hose from the FPSO will be connected to the shuttle tanker to allow the contents of the FPSO cargo tanks to be transferred to the shuttle tanker, an operation which would take around 24 hours. The high-quality accommodation module can house up to 100 persons, mainly in 1- and 2-bed cabins, although normally there will be less than 60 crew on board.